Okay, again, good morning, everyone. My name is Daniel Brown. I'm one of the senior hurricane specialists at the National Hurricane Center. We're so glad that everyone could join us this morning for our Hurricanes at Home webinar series. We have planned this to be about an hour this morning. About the first half of that, we'll provide a presentation talking about hurricanes and hurricane hazards and how we forecast hurricanes. But then we're going to give plenty of time for you to ask us questions. And you do that by entering your questions in the questions tab. And I see a few people have already at least said hello this morning to us. Someone mentioned that they are having difficulty hearing us. Hopefully that's not the case for everyone. You may have to turn on your computer audio. And if that doesn't work, there is a phone that you can dial to also hear the audio. But we will be again, taking those questions at the end, giving you a chance to ask those. We'll have the panelists up above that I'll introduce here in just a second. But first, as we get started, I wanted to introduce you to some of the Texas hurricanes. So unfortunately, Texas is no stranger to hurricanes. History shows that Texas gets hit by hurricanes about once per decade, can also get tropical storms more frequently than that. And even tropical storms, as you'll learn today, can produce flooding rains and devastating impacts. But some of the hurricanes that have hit Texas through the years, you go all the way back to Hurricane Celia back in 1970. And of course, there are ones before this as well. But Hurricane Celia was just a little bit before I was actually born. Back in 1970 was when it hit Texas. And we've had other hurricanes such as Alicia in 1983. Allison was a tropical storm that produced devastating flooding around Houston. And then more recently, hurricanes such as Rita, Hurricane Ike, and then Hurricane Harvey just a few years ago. These are the hurricanes, and we're glad that you could join us this morning because, again, we want to talk about things that you maybe can do to help your family better prepared and better learn about hurricanes and these storms. So with the next slide, John, I'm going to start introducing our panelists this morning. Up in the top left corner there, you see Robbie Berg. He's another one of our hurricane forecasters at the National Hurricane Center. So Robbie's going to help me moderate our question and answers this morning. So I'll let Robbie say good morning.
Hey, good morning, everybody. Welcome, and thanks for joining us this morning. And if you have any questions during the webinar, go ahead and type them out in the little box you see there on your screen, and then we'll try and get to as many questions as we can at the end of the webinar.
Yeah, thanks for reminding me of that, Robbie. We'll try to answer a few of those questions during the webinar as well, but we'll save some of those best questions for the end. You see me there. Again, I'm Dan Brown, one of the hurricane forecasters as well. I'm also joined by John Cangialosi. He's going to start off our presentation in just a minute. I'll let you say, hey, John.
Hey, hello, everybody.
And then Andy Latto, another one of our hurricane forecasters. He's going to take us through the second half of the presentation this morning, talking about those hurricane hazards and how we forecast storms. So good morning, Andy.
Hey, good morning, everybody.
And then you see a very special person up in the upper right-hand corner. He's Barry Goldsmith. He's the warning coordination meteorologist at the National Weather Service office in Brownsville, Texas, covering South Texas and the Rio Grande Valley. We're going to be joined shortly by Melissa Huffman. There's actually some active weather later today in Texas, and she's doing a webinar with some emergency managers right now, but she's going to join us as soon as she can this morning. So we'll introduce her a little bit later. But Barry, I'll let you say good morning. And again, thanks for joining us. You know, it's really important. Hurricane Center, we do a lot of the big picture forecasting, but it's the local forecast offices that really tell people in Texas and those local areas what they should be doing. So good morning, Barry.
Good morning, everybody, and thanks for the invitation. We'll be glad to answer any questions that you have for the local areas here in the Rio Grande Valley.
Thanks, Barry. So with that, I'm going to go ahead and turn things right over to John, and John's going to take it away and do the first half of our presentation this morning.
All right, thank you, Dan. Good morning again, everybody. Hopefully everybody's doing well. We're super excited to talk to you about hurricanes today. Hopefully you're all excited to learn as well. So I got a question for everybody right from the beginning. Can you tell me what a meteorologist is and what they do? Now, when most people think meteorologist, I think they typically think of someone who's on television telling you what the weather is going to be like. And that can be a meteorologist. But a meteorologist is really someone who studies or forecasts the weather for their job. So they could be on television, they could be forecasters like you're talking to today on this webinar, or they could even be doing research to try to figure things out for the future. Here's the message for everybody today. If you're out there and you're interested in math and science and have a fascination for the weather, I think you have what it takes to be a future meteorologist. So keep that in mind and ask us all the questions you want today to learn more about this field. Now, obviously today we're here to talk to you really about one specific type of weather, and that's hurricanes. So greetings from the National Hurricane Center, which is located in Miami, Florida. I wish I could be in the building with you guys today to show you around, but hopefully this is the next best thing to give you an idea of what we do. So take a look at the pictures you see here on the screen. You see these here? This is a picture of our facility. And you might be looking at that building and saying, that's not very pretty. And you'd be right, it isn't very pretty, but it is very, very strong. It's made of concrete and steel. And the reason it's designed that way is it's supposed to keep us safe regardless of how strong of a hurricane affects us in South Florida. Now at the Hurricane Center, we have a really big job, everybody. We don't just forecast for tropical storms and hurricanes for the United States. We forecast for a much bigger area. If there's a tropical storm or a hurricane anywhere between Africa all the way into the Pacific Ocean to pretty close to Hawaii, we are hard at work watching those weather systems and making some predictions. Now, the National Hurricane Center also has another big job. We also tell boaters, big ships, and other people who spend time on the ocean what the weather is going to be like. So if you were going on a cruise, or if you're going deep sea fishing, or if you know someone working on an oil rig like this one, we want to tell everybody to keep them safe what the winds are going to be like and how high the waves are going to be. Now, you might have also heard of the National Weather Service. Now, where is that? Where's the National Weather Service? Well, the good news is the National Weather Service is essentially everywhere across the United States. There's 122 local weather forecast offices that cover the whole country like you see here. And I'm sure you don't live that far away from where a National Weather Service local forecast office is located. And as Dan said in the beginning, we are lucky enough to have 2 meteorologists here today with us from the National Weather Service forecast offices. So let's meet them and talk to them in a little bit more detail. So Dan, is Melissa yet on the line?
I am. Can you hear me?
We can, Melissa. So if you don't mind telling everybody listening today what you guys do at the National Weather Service Corpus Christi office.
Good morning. I'm so excited to speak with all of you. So the Corpus Christi office, it's like where Barry's from in Brownsville. We cover a good portion of South Texas. And so we have 21 meteorologists, electronics technicians, and support staff who are all working behind the scenes to put out the weather forecast that you see. If you ever visit one of our beaches or Corpus, Victoria, a lot of our bigger cities, chances are you're working under a National Weather Service forecast. So we're just really excited to be talking with all of you today.
Thank you, Melissa. All right, how about Barry? Do you want to tell everyone what you guys do down in Brownsville?
Yeah, so hi everybody. To follow what Melissa said, we do those same things too. We serve an area known as Deep South Texas, which includes the Rio Grande Valley, which is over 1 million people and growing rapidly, one of the fastest growing regions of the state of Texas. We also have 21 meteorologists and technicians to help support our operations. You can see in the pictures here some of the things that we do. We release balloons, which include a instrument package that measures temperature, humidity, pressure, and wind through GPS. And we do that twice a day routinely, but during a hurricane potential moving into the Gulf towards the Texas coast or even towards the Atlantic coast, we'll actually issue those 4 times a day. So folks in the Rio Grande Valley, if you want to see us launch a balloon, we do that at 6 p.m. and 6 a.m. daylight time. Next picture there is one of our forecasters who's actually working on radar data, which is what you see in those pretty colors on that screen. The next picture there shows our media briefing room. So if we have a significant weather event, especially a hurricane, We will be doing briefings in there, potential press conferences in there, and briefing materials such as webinars like these to our partners and even the public in the Rio Grande Valley. So we do a lot of interesting things. One of the new things that we're doing is getting our staff out from behind the computer screens and into the community with providing what's called decision support for significant weather events, mainly to emergency management, but also to related partners in, say, public health, which is big right now, education, transportation, public works, such as keeping your power on. And we have a program called Adopt a Community where those staff will go out and meet the partners and provide direct support to them for events in their community, such as a county fair or a holiday parade. So those are just a few of the things we do day to day. But when a hurricane comes, that office that you see there on the second slide is packed with people providing information from warnings to public service to social media to help to keep people in the Rio Grande Valley and the ranch lands to our north safe from hurricanes.
Well, thank you, Barry. Great job to you and Melissa. And thanks for keeping everybody safe there at your portions of Texas. All right, guys, so let's move on now and talk specifically about the science of hurricanes. We definitely want you to learn something about how hurricanes really work. Now, on the screen right now, hopefully you can see this moving as I put it into motion. This is what a hurricane looks like from space. Now, if you live in Texas, you probably remember this hurricane. This was Hurricane Harvey that affected Texas in 2017. And I bet I know what catches your eye right from the beginning. Is it this big hole right here in the middle? That's called the eye of a hurricane. And the eye is just a weird place. It's sort of a weird quiet. Because in the eye of a hurricane, it's often almost calm and sometimes even sunny right here in the eye. But right around the eye is where things get really strange, in the eye wall region right here, where the winds are the strongest and where the rain is often the heaviest, and unfortunately where the damage tends to be the worst. Beyond that, in these areas here are the rain bands, which can be really gusty in the rain bands, and there can even be some tornadoes. Now, I want you to take a big look at this. Just take a big look, and I'll try to put it in motion again so you can appreciate it. You can almost imagine that the hurricane's kind of beautiful, right? From space, it's really amazing. Mother Nature produces just some amazing things, but it's certainly hard to call a hurricane beautiful if one affects your area. All right, now you all know that we give hurricanes names, how we help talk about them and communicate them, but we also give them categories or groups. And many decades ago, there were these two men, and Robert Simpson, that worked together to develop a scale named after them called the Saffir-Simpson Hurricane Wind Scale, where Category 1 hurricanes have wind speeds in this range, 74 to 95 miles an hour, and Category 5 hurricanes have tremendously strong winds, where the winds are 157 miles per hour or stronger. Now today, I want to show you where the really strong hurricanes go, the Category 3s, 4s, and 5s. These are what we call major hurricanes. Do you think your area gets hit by major hurricanes? Well, let's take a look. Based on history, this is where we know, to the best of our abilities, where the major hurricanes have moved over the Atlantic basin. Now, most people watching today are from the state of Texas. So we're going to talk specifically about Texas in a minute. But for now, I want you to look at one of these lines. Now, where the lines are shaded in yellow show you where the storms were at their strongest. So if you're listening to us from Texas today, you can see a whole bunch of yellow lines near your area, meaning a lot of major hurricanes have hit that state. But Texas is not alone. All across the Gulf Coast, the state of Florida, the Bahamas, a big chunk of the Caribbean region, and even up the US East Coast. And guess what? Even Canada has seen hurricanes. The bottom line, everybody, is hurricanes need warm water for their fuel and energy. So as long as the waters are warm, hurricanes are going to have a chance to affect the areas where you live. So basically, everybody listening today, assuming you're somewhere near the coastline, can see a direct impact from a hurricane. But even if you're living inland, still, as you'll learn, hurricanes can be a big deal. So let's now zoom into the state of Texas, since that's the area we're focusing on today. And let's look at all of the Texas hurricanes that we know of going back to 1900. And as you can see, everybody, there's a whole bunch of lines there on the screen that go into Texas, meaning there were a lot of hurricanes that affected your state. Now, where the lines are red and purple, that indicates where the hurricanes were their strongest. And where they change color to blue and green, that indicates where they were much weaker. So here's the deal. If you're listening to us today from places like Brownsville, not far from where Barry is right now, or Corpus Christi, not far from where Melissa is right now, or the Houston area, or Beaumont, Port Arthur, you have seen the strongest hurricanes in Texas history. And you live in a very vulnerable spot to hurricanes. However, let's say you don't live near the coast and you live in cities like San Antonio or Austin or up to Dallas or Fort Worth. You're not completely off the hook. You might not see the worst impacts from a hurricane, but you could still see a lot of the significant ones, like the flooding rains, which I know if you lived in Texas long enough, you've certainly seen a significant flooding event, just like happened during Hurricane Harvey. All right. So as Dan mentioned, we're not going to let you completely relax during this webinar. We want to keep you guys on your toes, and we want to test your hurricane knowledge. So here is your first hurricane quiz. Now, everybody, this is a poll question. So after I read the question, you're going to see a pop-up appear on your screen, and we want you at home to select what you think is the correct answer. Are you ready to test your hurricane knowledge? Here's the quiz. When is the Atlantic hurricane season? Do you think the right answer is A, May through November, B, December through April, C, June through November, or do you think the answer is D, all year long? All right, I see the polling is open, so please select what you think is the correct answer.
So John, we've got the votes coming in. Let me give it a few more seconds to get all the votes in.
Okay.
Big response. We've gotten more than almost 90% of everyone that's watching has voted. That's great.
That's
Glad
really
everybody's
good.
paying attention. So I'm going to close the poll now. And
Okay.
let me see if I can share the results. I'm not sure that everybody sees them, but I'll tell you
Let's
that
see.
the number one answer, just a little more than half the folks said June through November, and about another quarter of the folks said May through November. So John, I'll turn it back over to you for the answer.
Okay, so the correct answer is, everybody, here it comes. The correct answer is C, June through November. Congratulations if that's what everybody picked, because that is the right answer. But Dan, those that said May through November, hey, you're not far off at all. In fact, having tropical storms or hurricanes in May does happen. So I would say, Dan, really, the majority that picked those two were really pretty much right. Fortunately, hurricanes don't happen all year long. Officially, hurricane season starts June 1st and ends on November 30th. It's about half the year. And Dan, you can still see my screen, right? You can see this one with the satellite picture?
Yes, John, I can see the screen.
Great. Now, I want to show everybody how busy it can be during the peak of the hurricane season. And you can see, and everybody, my colleagues, when I see pictures like this, I say, oh no, here comes hurricane season again, because check out how busy it can be. Now, this was from September of 2018. You see this big hurricane over here over the western part of the Atlantic? That was Hurricane Florence that went on to strike the Carolinas. This one over here in the middle of the basin was Tropical Storm Isaac that moved across the Caribbean Sea. This one out here was Hurricane Helene that went on and recurved out here over the eastern Atlantic and affected the Azores Islands way out here in the middle or eastern Atlantic. Then we had another system forming off of Africa that went on to become another named storm called Joyce. And we even had one here in the Gulf of Mexico that headed toward Texas, but did not quite become a tropical depression. It just goes to show how really busy it can be at portions of the hurricane season. And you might be asking, well, when is it the busiest? Well, take a look at this graphic and it will show you. Whether you look at hurricanes by themselves, which is shown here in yellow, or hurricanes and tropical storms together, which is shown in red, you get the same answer. That the peak of the season, or when we typically see the most hurricanes, occurs right here around September 10th. And in general, everyone, there are 3 months of the year where it's the busiest for hurricanes: August, September, and October. So don't be surprised if you don't see much going on in June or July, because it really needs to ramp up in terms of hurricanes in the late summer and in the fall months. So definitely be ready for that time period, but please be ready for the whole hurricane season. All right, on to our next hurricane quiz. Now for this one, everyone, we don't want you to vote. We just want you to hear the question and then you can scream out the answer, or if your parents are telling you to be quiet, then maybe just whisper the answer. Are you ready? Here's the quiz. What are the primary hurricane hazards or bad weather conditions? Do you think the right answer is A, high winds, B, storm surge, C, heavy rainfall, D, dangerous surf, or do you think it's E, all of those? I'm going to give you just a couple of seconds. All right. The correct answer, everybody, is E, all of the above. If you were thinking that, or if you shouted out loud, congratulations, that is the right answer. But in general, if you picked any of those, you really weren't wrong. They're all very important, significant hazards when it comes to hurricanes. Now, to help you to remember the hazards, we came up with a word for you to remember, and I think this will help everybody. The word is called swift. The S in the word swift stands for storm surge, which Andy's coming up next and will tell you all about storm surge. In a nutshell, storm surge is the water over the ocean that gets pushed by the strong winds and floods neighborhoods where we all live. The W in the word swift is wind. Of course, you all know it's windy in hurricanes, so I'm sure you didn't have to remember that one. The I and the F stands for inland flooding, which could be a really big deal. And the T for tornadoes, which, as we mentioned earlier, can happen in some of the hurricane rain bands and cause a lot of local damage as well. But we also want you to remember one more hazard: the big waves and rip currents. Even if a hurricane doesn't affect your area, it can still produce big waves and really rough beach conditions in your area. So make sure to pay attention to your local meteorologists and the local officials about when to stay away from the beaches. Please keep that in mind. Sometimes it can be a beautiful sunny day, but the beaches are just an unsafe place to be. All right, on to another hurricane quiz. Now, everyone, just like before, we do want you to vote for this one. So get ready for the polls to be open very soon. Here's the question. Which hurricane hazard that we just talked about has caused the most deaths, unfortunately, in the United States? Do you think the right answer is A, wind, B, storm surge, C, flooding, or do you think it's D, tornadoes? All right, the polling is open, and from here, I will be passing it to Andy.
Okay, John and Andy, I'm watching the votes come in again. A lot of folks voting. Give it another few seconds. More than 80% of you have voted. That's great. Okay, almost 90% now have voted. Great job, everyone. I'm going to go ahead and close that poll. And I'll see if I can share the results real quick. So it looks like, Andy, about 4 in 10 people said flooding. Another third of the folks said storm surge. And then a few more said tornadoes and wind. So I'll let you give the answers.
All right, thanks, Dan. And hopefully all you folks can hear me out there. So the answer to that question, and it looks like about a third of you said storm surge. Yeah, a little over a third said flooding, and that's really good. The answer is actually storm surge. Now, when I was growing up, I grew up in Western Florida. Whenever a storm would get near our place, we lived a few miles inland. Whenever that storm would get near us, I would see a lot of palm fronds falling from the trees. You see pictures in the media showing debris like you see on the screen here. And so in my mind, wind was the big deal. You know, that's what they caused. But in reality, and that's what most people think about. But water is what most people don't think about, but really, really should. The picture you see over here on the top left is
Andy, we might have lost, at least I did, I lost this screen, so you might have to reshare the slides after we came off the poll, just so that folks.
Can you see me now?
Not yet, but maybe John can help in a second and we can run them from there.
Okay. I'll switch to John and then back to myself, see if that doesn't fix it real quick.
There we go. We got it now.
All right.
No worries.
Okay, so the top left-hand picture you see here is water rescues going on. And the bottom left is what we call storm surge. So there's a difference between heavy rainfall flooding and storm surge flooding. And so the bottom left is actually the ocean waters being pushed on shore as a hurricane's moving inland. And you can see the amount of flooding is inundating that car there. And storm surge, it can be very deadly. And about half the deaths that occur from tropical cyclones are from storm surge. But if you look at the pie chart on the right-hand side, all the bluish kind of colors are indicative of water-related fatalities between storm surge, flooding from rainfall, and other, offshore flooding, fatalities that occur offshore, or from, like John was talking about, from rip currents and surf. 9 out of 10 people die from water, not from the wind. So it's very important to keep that in mind with regards to hurricanes. So storm surge from Hurricane Sandy. Hurricane Sandy was a very large, sprawling tropical cyclone that moved inland up in New England back in 2012. Here's a picture of Manhattan, New York on a typical day. You have folks walking across the street. You have cars driving around the area. I want you to pay particular attention to this restaurant that's located at this corner here. And when Hurricane Sandy came through, the waters from the ocean moved inland and in normally dry areas. And so you see the water is up a few feet up high on this storefront here. So any folks that were probably living in here had to wait until those waters receded to be able to come outside of that building. This van is about halfway underwater. So this water is at least a few feet deep inside the Manhattan area. When I describe storm surge, I like to describe if you're at the beach and you go into the water and the water's moving around quickly and a wave hits you, it can knock you over. Water is very heavy, water is very dense. And so when you have water moving inland as a tropical cyclone moves inland, it's very forceful. It takes from Hurricane Sandy, which wasn't even a major hurricane at the time, took houses and just moved them around. It took them off their foundations and pushed them inland. It destroyed other houses as well. Storm surge is very powerful and can be very dangerous. And that's why when evacuations orders are given, it's very important to heed those warnings because that means storm surge might be affecting your area. When we talk about the difference between storm surge and flooding rains, so when we have very heavy rainfalls from tropical cyclones, and in this example I'm going to show you is actually just a tropical storm, Allison, so it was not a hurricane, those can be very deadly as well. What happened with Allison is it produced very heavy rainfall over a short period of time in the Houston, Texas area. And when you get lots of heavy rainfall in a short period of time, the ditches, the tributaries, the rivers cannot handle the amount of water coming in from the runoff from your roofs and roads and whatnot. And so it has to find somewhere else to go. And in this case, it found Interstate 10. And so it flooded Interstate 10. And what you see, these little white things all over the place are semi trucks. They're trapped in those flood waters. And those waters are at least several feet deep right there on the interstate corridor. And yes, tornadoes and waterspouts can occur during hurricanes. They do cause fatalities as well. So the difference between the waterspouts and the tornadoes basically is a waterspout is over water, tornadoes are over land. And yes, waterspouts, like for example, the one in the bottom left-hand corner, can move into land like you see on the right-hand side. So they occur in both locations. And they can have winds just as strong as a hurricane, but it's in more of a smaller confined area. And as John was talking about earlier, waves and rip currents. It could be a sunny day on your beach, and there could be waves and rip currents caused by a hurricane well offshore that might not ever come to your area. What happens is these storms produce very large waves, and those waves propagate away. When they reach the shore, they push a lot of water up onto the shore as a big wave. Well, that water goes back out into the ocean. The bottom left-hand picture, you kind of see that. What happens is a channel kind of develops along the shallower waters. And if you get stuck in that channel, that's what's called the rip current. It pulls you out into the sea. And there's ways to escape if you try to swim parallel to shore. John was also talking about there's different ways to warn you how the conditions are going to be out there because it might be a nice day. There's rip current statements that your local weather forecast offices can issue, indicating to you that those conditions could be hazardous. There also can be flags located at the beach that we see in the middle of the screen here that kind of tell you whether or not it's green, safer, or red, very hazardous, to stay out of the waters. So we talked all about these hurricane hazards and how frequently they can happen. How do we predict them? How do we know how strong they're going to be? How do we know where they're going to go? We have tons of data we have to look at on a regular basis as it comes in to try to determine how strong the storm is and where it is. So we have surface observations from around the country at those weather forecast offices as well. We have ships out there, even cruise ships and cargo ships can relay information to us as they're passing nearby these systems. We have buoys across the oceans that can give us those data as well. We have upper air data. We launch weather balloons across the country that tell us what kind of conditions are in the atmosphere. There are aircraft that are flying around out there and can go into the storms, and I'll talk about that in just a couple minutes. Pretty cool. We have satellites, and John showed you that picture of Harvey earlier, that really neat loop. So we have satellites that are taking pictures constantly of Earth and sending them back to us. And that bottom left-hand picture here shows you, it's a snapshot. It tells you where the storm is, and we can determine also how strong it is based on how the storm looks. If the storm's near the coast, we can have Doppler weather radar. Just like we monitor severe weather inland, we can monitor the weather that's associated with the hurricane as it moves close to shore. Most of this data can go into sophisticated computer models that will then try to simulate how strong the hurricane will be and where the hurricane will go. Us at the Hurricane Center are looking at all this data, and there's a lot of different computer models as well. We're trying to look and determine which of those ingredients that are going into making the storm strong and what's driving that storm to try to determine which direction it's going to go and how strong it's going to be when it gets there. And I talked about flying the airplanes and the hurricanes. Us at NOAA, we actually have two different types of aircraft. The one on the top left is jet propelled. That aircraft tends to fly a little higher in the atmosphere to try to fly around the environment surrounding the hurricane. They try to tell us what the steering mechanisms are and what kind of environmental conditions might be conducive for it to strengthen. The other two aircraft are propeller-driven aircraft. The one on the bottom is actually Air Force aircraft, and there's a lot of those aircraft that fly in and out of the hurricanes throughout the season. Those actually go into the hurricane and give us measurements of what's going on inside the storm, as well as what's going on in the environment. And those aircraft do penetrate the eye wall and actually go inside the eye of the hurricane. So this is what it looks like when if you're inside one of those reconnaissance aircraft, inside the eye of a hurricane. We like to call this a stadium effect. So pretend you're standing in the middle of a football field and you're looking up towards the side of the stadium. You're seeing all the chairs that rise up to the side to the upper deck. That's essentially what the eye wall is basically that wall of seats. And as John was saying earlier, the eye can actually be very calm. There's a lot of sinking air in the eye from the surrounding storm, and so the clouds are a lot lower as if you're on the field in that particular stadium case. So how do we tell people about the forecast? Well, when there's a hurricane approaching, there is a lot of media in the building. There's folks you see, this is actually inside the Hurricane Specialist Unit Operations area. Folks are doing television interviews, telling people about the hazards of the storm, what's going to be affecting their area the most, what's the biggest threat. There's also a lot of phone calls that come into our operations area from radio and newspapers trying to get additional information about the storm. We can also relay that information through social media. We talk to the state and federal emergency management about the potential threats from the storm. And what those folks do is they will send that information down to the local emergency officials, and they will help decide who to evacuate and how kind of preparations and the timing of the preparations for everybody that might affect you locally. So how do we get the information directly to you? Well, there are direct ways, and we'll show you the web link here towards the end. We have our own website, hurricanes.gov. We're on Facebook, and actually, when there's a storm threatening, if you saw one last year, the guys, our director, Ken Graham, would do Facebook Live. So he actually has a video where he's walking around the operations area talking about what's going on with the storm. We're on Twitter. We will send several tweets throughout the any small time frame when there's a threat for a storm. You might see the key messages. You might see updates on position. We're also on YouTube, and we also have a blog that we have a lot of stories we talk about from some of our experiences. Our Twitter handles are NHC_Atlantic and NHC_Pacific, and on Facebook, we're NWS_NHC. Coming up here in the next month or so, we have Hurricane Preparedness Week. I want you to notice the URL at the bottom, though. This is a very good website that has a lot of information. So if you're curious about, okay, what do I need to go to the store to buy to get ready for hurricane season? What do I need to do to prepare? If I need to develop an evacuation plan, am I in an evacuation area? Go to this website. It has a lot of information on how to prepare for the upcoming season. It's weather.gov/WRN/hurricane-preparedness. You can see that link there at the bottom. I want to thank everybody for joining us. At this point, if you have questions, Dan and Robbie are going to start fielding some of the questions that you're typing in there. And all of us folks here are going to be happy to answer some of those here.
So thanks, Andy. Great job. We did get a lot of questions, and I know Robbie and we've been answering some of those as they've been coming in. So thank you for those questions. Hopefully you've seen some of those answers. I did get a great question I wanted to save for this period. I think it was from Brooke. And I'm going to send it over to either Melissa or Barry, because I think it's a great question for you all, since you are the offices that help launch those weather balloons. But it was, how do we get the information about the weather from the balloons? So I'm going to let you guys, one of you answer that. Maybe you want to both comment on that.
I'll let Melissa go first.
So when we launch these weather balloons, and like Barry said, we launch them twice a day, we basically blow up these big balloons and tie an instrument that's known as a radiosonde to it. And so it kind of looks like, if you've ever had a takeout box from a restaurant, it kind of looks like that. And it contains all different kinds of instruments. So it measures temperature, it measures humidity, it actually gives us wind information, and it sends that all back to our weather service offices by radio frequency. So it's actually giving us these transmissions by radio. And so you can actually look at the information that gets, it's like a snapshot. So you can actually look at this snapshot that all the meteorologists look at online. And that's actually available. So we're talking with the Hurricane Center today, but all of those snapshots are actually available through the Storm Prediction Center's webpage. And it's all free, and you can look at it. And it's really neat because as the balloon goes up and sends us all of this information, the balloon actually gets really, really big. So the picture that Barry showed, the balloon gets so much bigger than that as it moves up in the atmosphere. It can actually be as big as a house by the time that it pops. They go up over 100,000 feet. But I love this question because I love balloon launches. It's really fun. We get to do a science experiment pretty much every time we launch a weather balloon. So thank you for the question.
Robbie, I'll pass it over to you to see if you have a question you want to ask.
Yeah, so we have a question here from Melanie. She says, why do you name hurricanes? And I guess associated with that is how do you come up with the names with the hurricanes? So maybe John, I don't know if you want to take that question and answer that.
Sure, Robbie. So how do we name her? Why do we name them, and how do we name them? So obviously we name them to help communicate about them, and that's been happening for decades. So how do we come up with the names, and how do we figure out what name to replace it with? Well, there's a running list. The names repeat every 6 years, and if you want, you can actually see what the names are expected to be for this hurricane season and for the future ones. You'll notice that the names change from boy girl to boy girl, or the other way around. And there's also some Spanish names, some French names, and some English or American names, because those are the countries and places that sees hurricanes. Now, when a hurricane really causes a lot of damage, or unfortunately a lot of deaths, then the countries that were impacted by that hurricane will then get together and decide to retire that name, mostly for sensitivity purposes, because the storm was so bad. And then that team, which is through the World Meteorological Organization, will then pick another name to replace that one. So for you in Texas, everybody, there won't be another Hurricane Harvey or Hurricane Ike, for example, because those produce so much damage that we came up with names to then replace those. So those won't be used again.
Thanks, John. I have a question here. I think I'm going to turn it over to Barry for this one. It's and maybe Melissa wants to answer too, but it was from Elizabeth. She asked, "What was the worst hurricane in Texas?"
So I'll do the best I can on that. In terms of damage value, it is Harvey at this point. I think $125 billion, and I believe $100 billion of that was related to flood damage, mostly in southeast Texas from the Houston, Galveston area over to Beaumont, Port Arthur. There's also been some legendary storms in the past that make Texas history rather interesting. There were 2 storms that hit a community known as Indianola on the central Texas coast. I think one was in 1875 and one was in 1886. And the double whammy of those wiped that city from the map. There's, I think, just an outpost there now, but it was once a thriving area. And then I think one of the most memorable ones in the past is the Great Galveston Hurricane of 1900. Galveston was a thriving port, and Houston was kind of a cattle town at the time. And what the 1900 storm did was, number one, it was the most deadly hurricane on record in the U.S. I believe anywhere between 8,000 and 10,000 people perished. It's also known as Isaac's Storm. There's a book on that. Isaac Klein was in the Weather Service then and worked out of the Galveston office and literally went on a tour of the community and knocked on doors to help get people evacuated from it. But the future of Galveston changed dramatically. Houston became the economic center or hub of Southeast Texas. And Galveston remained important, but the population shifted inland dramatically after what the 1900 hurricane did. So those are just a few of the significant hurricanes in Texas. I'll let Melissa speak to some of the other ones on her coastline. I think Celia and Carla stand out.
Yeah, Carla is a big one. Harvey, a lot of people associate Harvey with Houston, but Harvey did make landfall in the Corpus offices area. And so even though a lot of people think of Harvey as a storm that produced a lot of heavy rain and flooding, we still did see Category 4 winds near Rockport with it. So it was, probably, at least, in my time in the Weather Service, the most memorable storm I've ever worked. And piggybacking off of what Barry was talking about with the Galveston storm, we've talked a little bit about Galveston. Ike was another storm that made landfall in Texas in 2008. And if you live in the Houston-Galveston area and ever make a chance down to Galveston Island, you can actually see how high the water got in parts of the city. So that's a really neat thing to do with your family if you've ever been around the Galveston area.
Yeah, thanks, Barry and Melissa. Those were some great answers. I know Texas has had a long history with storms, so it's good to see everyone asking great questions about Texas storms. Andy, you were talking about, in your part, about how we watch hurricanes. And actually, we had this question from Colton where he asked, what causes a hurricane to change directions? And I was wondering if you could answer that question for Colton.
Sure, Colton. So I'd like to describe a hurricane in moving around is like a cork in the stream or a leaf in a stream. And so it's kind of just being driven along by the atmospheric currents. And so we talk about, I don't know if you've heard about high pressures and low pressures. And so in the atmosphere, especially in the mid levels of the atmosphere, if you have a large area high pressure and it's to the south of it, typically you'll see it moving from east to west. Like a lot of storms you see moving across the tropical part of the Atlantic. What causes it to change direction? Well, let's say you have a cold front approaching the east coast of the United States. Well, the winds ahead of that cold front become south to southwest. And so what happens is as that storm goes around the high pressure area, it might turn and get caught up in those southwesterly winds, which causes it to turn and recurve and curve out to sea. And those scenarios happen all the time, any location. So it's depending on where the storm is, it might change direction near you, or it might move inland first before it changes direction.
Thanks, Andy. Great answer. John, I have one for you, and this is, to me, is a little bit of a tough one, and someone really, I think, that knows the science or must watch hurricanes a lot, because Preston wanted to know how eye wall replacements happen.
Wow, Preston is a smart kid. Very impressive, Preston. So, we're still learning more about eye wall replacements. First, I'll tell you, Preston, that we can't predict them very well. This is something we can observe. And here's what we know of eye wall replacement cycles, Preston. So we know when storms get really strong, like those major hurricanes we talked about before, category 3, 4s, and 5s, when they get really strong, they're more likely to have an eye wall replacement cycle. But they also have to stay in a very, what we call, a good environment for them to strengthen. So warm water and a high moisture and a low amount of what we call wind shear. If it can stay in that environment, what we see, Preston, is we see that eye wall we showed you earlier. That eye wall right near the eye starts to get small, and then a new one starts to form around it. And what's actually happening is that for a while, the hurricane actually has two eye walls. When that inner one starts to fall apart, the hurricane then weakens. But guess what happens, Preston? When that outer one I talked about starts to move in, then the hurricane re-strengthens. And it's like almost like a snake. Have you ever seen a snake? Snake has a skin, and then it sheds that skin, and then it grows one. It's almost like our hurricane's doing something like that. It's kind of crazy. I don't think we're Preston, maybe at one point, if you want to be a meteorologist, and it sounds like you have a chance given that you're fascinated with these, you can help us predict those at one point in the future. But for now, we can observe them and see when they're happening, but we really can't figure out exactly how it's going to happen. But great question.
Hey, thanks, John, for that question. So looking through the list of questions, you guys have so many here. I have a question from Natalie, who asks, can there be a hurricane and a tornado at the same time? Melissa, I was wondering if you could take that question.
So if anyone went through a Hurricane Harvey in the Houston area, probably one of the things that you picked up on is that there were a lot of tornado warnings, and it was a big tornado producer. But yes, you can actually experience a tornado during a hurricane. For the folks who live a little bit farther inland, Hurricane Gilbert actually did produce a lot of tornadoes around the San Antonio area in the 80s. And this was a system that was well inland by the time it started producing those tornadoes. But yes, you can experience a tornado and a hurricane at the same time.
Thanks, Melissa. I have one here I'm going to send over to Barry. This is from Cole. This gets in a little bit more about hurricane preparedness, something we all want to think about as we head toward June 1st. But his question is, what is the safest place to be in a hurricane?
Wow, that's a question that could take a whole hour to answer all the details, but I guess we'll start with the two places you could be. One is your home, and the safe place in your home would be when it comes in interior rooms or like a bathroom or a closet with multiple walls around you. You want to make sure you bring in items such as pillows and blankets, even a bicycle helmet if you have one, to protect your head in case there's severe damage inside your house. The issue though with that is if you're in a storm surge zone where that water from the sea can come in and flood your home, it may not survive, and there's a pretty good chance that you'll be potentially injured or even drown and get killed. So you need to have an evacuation plan, or at least your family would. So talk to your parents about where you might go if you live in a threat zone from water from the sea, or you're not sure that your home can handle hurricane force winds, or what we call major hurricane force winds of 111 miles per hour or greater. If you're unsure about that, you need to have an evacuation plan to a place that is safe. So that may be somewhere inland from the coast. It could be within the place what we know is Rio Grande Valley. It could be as close as McAllen if the forecast suggests the winds will be light enough and the rainfall won't be sufficient enough to flood. But more likely, you might go to a location like Latto, Texas, where it's 212 miles in from the coast. There's a better chance of getting through the event without having the impacts that you'll see near the coast, or Austin, San Antonio, Dallas, places like that. If you have family or friends there, that would be your best location to go. If you do decide to go there, however, this is the time of year, April, early May, to check that evacuation plan, make sure they can house you, make sure you can go there with your children, perhaps your pets, and have that plan ready to go in case the hurricane watches or warnings are issued. Because the last thing you want to do is make a last minute decision and not be ready. So whether you decide to stay or go, you need to look at those plans now and adjust them accordingly. And April and May is a great time to do that.
Hey, thanks
Thanks,
Barry.
Barry. Yeah. Go ahead, Robbie.
Yeah, so I was going to say, I'm looking at all these questions, and it looks like there's a lot of people that are interested in meteorology and predicting weather. And I have one question from John, who asks, what classes should you take in college for weather predicting and meteorology? And actually, Dan, I was going to toss it to you to see if you'd like to talk about where you went to school and like what kind of classes you took in order to learn to be a meteorologist.
Sure. I went to a fairly small meteorology school called University of North Carolina, Asheville. At the same time, I was able to work part of the National Oceanic and Atmospheric Administration's National Climatic Data Center, where a lot of weather records were kept. But you know, meteorology, it is a lot of math and science. You got to really like the math. Sometimes it's not easy, but it really helps you kind of understand how the atmosphere works. I also have to take a lot of physics, some chemistry, and again, you know, as Andy talked about, it's a lot about how the atmosphere flows and how it moves. And so you have classes called dynamics that we have to take to learn about things like that. I'm not sure if anybody else wants to add some of the classes. I'll also add, before I turn it back to Robbie, to see if anybody else has anything, is that you also really want to have a good communication skills. You know, if we make a forecast and nobody hears about them, then they're not going to do many people any good. So I know Robbie's done some work with communication, and again, it really helps to have good skills to be able to tell people what the weather is going to be, what they should be doing, a lot of like what we've talked about today, to help them prepare for severe weather.
Yeah, I was going to add, you know, when I went to college, I went to North Carolina State University in Raleigh, North Carolina, and I also majored in meteorology, took all those physics classes, but I also took oceanography and majored in that as well. Because it's not just the atmosphere that we're worried about, but those storms, hurricanes, they feed off the ocean. So we have to understand how the ocean works. And then the storm also produces storm surge. So that's all part of oceanography as well. And then as Dan talked about, communications is important. And I actually went back to school after I'd already gotten my job to get a degree in communication, because I wanted to learn how to better talk about these storms to people when they're actually occurring. So it's not just physics and meteorology and math. Sometimes you can broaden your perspective and your horizons and focus on other things like computer science or communications or psychology. That you can somehow take all those different fields and put it into meteorology. It's a really fascinating world we're in right now when it comes to those fields.
Thanks, Robbie. I saw one here that was kind of asked earlier that was kind of interesting, and I'll turn it back to you for this one since you turned the last one back to me. It says, have we ever, let me find it again here. It asks about, have we ever been wrong about a hurricane prediction? And I would say yes. Unfortunately, hurricane forecasting is not an exact science, but I'll let you describe how we talk about uncertainty in a lot of our forecast products so that people can help plan even when the forecasts aren't perfect.
Yeah, so you know, we try to do our best as meteorologists to make a perfect forecast, tell you exactly where a storm's going to go, exactly how much wind it's going to produce, exactly how much storm surge it's going to produce. But we're just not that perfect. There's so many things going on in the atmosphere that it's called almost like chaos theory, and it's hard to pinpoint exactly what's going to happen. So there's always going to be some uncertainty when it comes to the forecast. So unfortunately, yes, there have been times where we've been wrong about a storm, at least wrong and exactly where it's going to make landfall or exactly how strong it's going to get. So what we have to do is tell people that even though this is our forecast, we think that the storm could maybe move over here, maybe move over there, that everybody along a certain portion of the coast has to be ready for the storm, just in case it wobbles around a bit and doesn't move exactly where we think it's going to move. So there are some storms, like Hurricane Dorian last year, they hit the Bahamas, caused a lot of damage. And unfortunately, in the days before Dorian, we didn't know that Dorian was going to essentially stall or stop moving right over the Bahamas. We thought that Dorian was going to move over the Bahamas and then reach Florida in another day or two. And unfortunately, that didn't happen. The storm stalled. It just stopped moving and sat over the Bahamas for about 2 days. That just caused a lot of wind and storm surge damage over those islands. So while we didn't initially know that was going to happen, once the storm did start slowing down, we knew that that could be a possibility, and we were able to tell people about that once it looked like it was going to happen.
Thanks, Robbie. I don't know if you have another question ready. I know we're getting short on time, so we might have to wrap it up here fairly soon. I was just going to kind of look through the list, see if I had any other ones I wanted to ask, but I don't know if you have one ready.
Yeah, so here's a question actually that I think everybody can answer, because there's so many different things that come into play here. But Tima is asking, what affects a hurricane's strength? So I wonder, maybe we can go around the horn and everybody can give a different parameter, if you want to call it that, or characteristic that can affect a hurricane's strength.
I guess I can start out here, Robbie. One major factor is how warm is the water temperatures below the storm and how deep those warm waters are. We like to say 26 degrees Celsius is kind of a magic number, but you see most of the time in the summertime, Gulf of Mexico, Caribbean are very warm, like bath water. So those warm waters are very conducive for intensification.
All right, I guess I'll go next. How about a very humid environment? So hurricanes, produce a lot of rain. Obviously, we talked about that. So they like to get stronger and bigger in these very moist, humid environments. So that's another thing we watch for.
I think another thing that, we also look at is what are our winds doing as we move way high up in the atmosphere? So are they going to help that hurricane strengthen more, or are they just too strong to keep it from getting any stronger?
I can add that at least for the forecast, as you talked about, Andy, hurricanes need warm water. We want to make sure that they, if you're a hurricane, you want to stay away from land. And so if a storm does hit land, it tends to weaken. Can be good news for folks on land because, again, the wind speeds are going to come down. But for a hurricane, that's not good news. So we have to account for that as we make forecasts, whether the storm's going to be impacted by any land, and especially land that's very mountainous, like some of the Caribbean islands.
I think we got most of the big ones.
I guess the only thing I would add, maybe this is another question related, is that, there's more to the story than the category. The category is based on wind only. And so if you look at a storm like Harvey, when Houston was getting the tens of billions of dollars in damage from rainwater flooding, up to 60 inches of rainfall, it was a tropical storm at that point. It's no longer a hurricane, it's still producing that kind of incredible rainfall. We had one last year known as Imelda that hit some of the same areas with over 40 inches of rain, also a multi-billion-dollar damage producer for flooding. So from the Hurricane Center, collaborating with the local offices here in Texas, we will provide that forecast information based on the SWIFT. So we'll look at the situation and kind of rank what parts of the SWIFT will be worse than others. And if you live inland, your winds may only be tropical storm force, so the W part of SWIFT may not be too much, but the IF, the inland flooding, could be off the charts. And if you're not prepared for that, you might get surprised, and we don't want anyone to be surprised. So we're here to tell you about all the SWIFT and communicate those impacts effectively so that you can make the best decision for you and your family.
Thanks, Barry. We're got to wrap up here. I see it's about 11 o'clock Central Time, so we do need to wrap up. Again, I've seen some great comments from folks thanking us for putting this together today. We really thank you for joining us. But I do have one final question I was going to go around and let everybody answer. I see Melissa may have had to drop off due to weather and other things. Perhaps she'll rejoin in a second, but if not, we do thank her for joining us. The last question I had is, so we've had a lot of folks, and there may be folks on this call that were interested in meteorology, want to make science a career. Just go around the room. Do you have any advice that you would give to anybody aspiring to make science or meteorology a career? I'll start with Robbie, and then maybe we can work around.
Yeah, I mean, kind of go back to what we were talking about earlier, is that, focus on the subjects that you're going to need once you get to college to learn about meteorology. Unfortunately, you have to know a lot of math, you have to know a lot of physics, and those are important subjects. So, do your best in those subjects now, because then when you get to college, you'll be ready to go. You'll be ready to get right into weather and learn about what makes the atmosphere do what it does. It's a pretty fascinating field.
John?
Sure, I'll add, in addition to those subjects that Robbie talked about, keep the passion that you have for weather. Observe everything you can, whatever catches your interest, do your research, continue to learn, and I always say weather's like an open book in the sciences as well. There's a lot more we need to learn. So I think plenty of learning to do. You can just about learn every day. So keep up that passion and follow your dreams.
And Andy?
So I found when I was of course going to school for meteorology, doing the math and science, but something that I felt helped me get into the weather service was that I was able to volunteer. I volunteered at one point at a TV station to see how things go and work behind the scenes. That was kind of cool, fun experience like that. Or volunteer anything that has to do with weather. I mean, you can volunteer for the Red Cross, for example, after a storm or anything like that. You can somehow connect with your community in different levels to actually learn how things work in addition to the math and science.
And Barry?
Yeah, this is great starting point. My take is be willing to expand your horizons. Once you start doing the weather and the math and the physics, it's all great. But if somebody had told me when I graduated nearly 30 years ago, or more than 30 years now, that I'd be doing things in psychology, behavior, social studies, I would have laughed at them. But believe it or not, communication is important to multiple groups of people that you may not understand without understanding geography, location, place, and their social situation, because our number one mission is to protect life and save life. And if the message isn't understood and people don't take the action required and they don't survive or they get injured, then we have to figure out why. And by understanding how the social sciences work, we're going a long way to improving how we communicate these threats and impacts.
Thanks. For me, I'll just add real quick that for me, my job is more of like a hobby than it really is a job. And I've really enjoyed what I do and the fact that we can help others. I would encourage you to find something that you enjoy to do to make that your career. And if it is science and math, as others have said, now is the foundation time to study to get the first part of that math and science down, because it will only build and get harder in the future. But I know that everyone out there can do it. We all did it at one point or another. And again, I've really enjoyed our careers. I'll wrap up by again saying thanks so much for joining us. I know we did not answer every question. There were lots of questions. In fact, it looks like we had a smaller number of people attend than we did the webinar on Tuesday, but yet I think we had 2 or 3 times more questions. So you all were a very engaged group, again, asking lots of really great questions. Really appreciate all those, made it fun for us. Hopefully it was fun for you. I see a lot of thank yous from many of you. So again, thank you for those kind words as well. A couple websites on the screen. Hopefully you got those down. You can find more information about hurricanes on hurricanes.gov and also the weather service at weather.gov. So again, we really appreciate you joining us. Thanks for taking the time, and stay safe, everyone. Hurricane Center signing off. Thank you.
Bye, everybody. Take care.